When a massive star reaches the end of its life, it goes out in a blaze of glory, a supernova, a cataclysmic explosion that outshines entire galaxies for a brief moment. The star's core collapses, and the outer layers are hurled into space, creating a supernova remnant, an expanding nebula of gas and dust. The cosmic cycle of massive stars is a dramatic process that plays a crucial role in the evolution of the universe. These stars are much larger and more massive. This nebula will glow for thousands of years, a beautiful but fleeting memorial to the star that once was. Nebula. Massive stars form in large molecular clouds, often called stellar nurseries. Gravity pulls together the gas and dust, forming a protostar. But this is not just an ending, it's also a beginning. Protostar phase. As the protostar accumulates more mass, its core temperature rises, eventually igniting nuclear fusion. This marks the birth of a star, where hydrogen begins to fuse into helium. 2. Main sequence stage. The remnants of the exploded star, carbon, oxygen, iron, and other heavy elements, are now part of the interstellar medium, stable fusion. The star enters the main sequence, where it remains stable for millions of years. During this stage, the star fuses hydrogen into helium in its core. Over time, this mixture of elements becomes the building blocks for new stars, planets, and possibly even life itself. Energy output. The balance between gravitational forces and the outward pressure from fusion keeps the star stable. This cycle of death and rebirth is a cornerstone of stellar evolution. Fuel depletion. Once the hydrogen in the core is exhausted, the core contracts and heats up, causing the outer layers to expand. The star becomes a red supergiant, dramatically increasing in size. New stars form from the enriched gas and dust, burning brightly and continuing the cosmic ballet until their time too comes to an end. Heavier element fusion. The core continues to fuse heavier elements like helium, carbon, oxygen, and eventually iron. Each new stage of fusion releases. But even in death, these stars contribute to the next generation, enriching the universe with heavy elements. Iron core formation. Iron builds up in the core, but unlike lighter elements, iron fusion does not produce energy. This leads to a catastrophic loss of pressure support in the core. This cosmic influence is profound. Supernova trigger. The core suddenly collapses under its own gravity, leading to a dramatic increase in density and temperature. This collapse happens in a fraction of a second, creating a neutron-rich core. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the heart of a massive star that ended its life in a supernova. Shockwave. The collapsing core generates a powerful shockwave that travels outward, causing the outer layers of the star to explode in a super. The life cycle of a star, from birth to explosive death, is a fundamental process responsible for creating the elements that make up everything we know. Elemental creation. The supernova creates and disperses many of the heavier elements, beyond iron, throughout the galaxy, contributing to the cosmos. It's a reminder that we are all connected to the stars, made from the same ancient stardust. Neutron star. If the remaining core after the supernova has a mass between 1.4 and 3 times the mass of the Sun, it becomes a neutron star. Neutron stars are incredibly dense, with a radius. Each supernova is both an end and a new beginning, leaving a legacy that echoes through time and space, enriching the universe and continuing the cycle of. Don't forget to subscribe to the channel and activate the bell to receive everything new.